Hello everyone, Spaniard here again. Today I'm just going to be talking about the 2019 asteroid that hit the moon in January. Between January, I think it was January 20. It says here. Now this is just a follow-up video to my video from last night about the Apophis and Bennu asteroids. Now it's crazy because this lunar impact of this asteroid happened during a total lunar eclipse. Now the asteroid was just between 1 to 2 feet across and weighed only about 100 pounds. It hit the surface at 38,000 miles an hour, and it was equivalent to 1.7 tons of TNT. It left a crater about 50 feet wide. So we're talking about a rock that was at least 2 feet, or at max 2 feet across, weighing only 100 pounds, that did 1.7 tons of TNT worth of damage and created a 50-foot crater. So a 2-foot meteorite created a crater on the moon 50 feet wide. So this is just a comparison as to, this is the explosion here. They caught it happening on camera. But it was obviously during the lunar eclipse, which was a pretty interesting event. And there's the explosion there. So I just made this quick video just to give an idea. Now Apophis not only is going to come close to the Earth, it seems like it might come even closer to the moon. So I just made this video as kind of like an example. It's funny because we had that total lunar eclipse this year that happened, when was it, last month? Or this month? Total lunar eclipse. Yeah, it was in mid-May, which I did happen to take photos through my telescope, and it was a pretty cool event. I don't think anything crazy like this happened, but still pretty cool. Lunar eclipses are cool. But yeah, it's pretty wild. Well, that was it. It was just to make this quick video. But I'm definitely gonna keep track of those two. I really wanna get a photo of the K2 Panstarrs comet. The K2 Panstarrs 2017 comet. I also mentioned in my video from last night, this guy is a big one. Now, of note, now that I'm talking about it, of note, I should mention that this guy is between was it K2 or TV? I think it was K2. Hold on a minute. I felt like I saw I think this one was mentioning that it's like at the minimum 9 miles radius of 9 miles, the nucleus of this K2 Panstar. So this one's a big rock. This one's a pretty big one. It's funny because it's right here, look. Comet nucleus. It's the solid central part of the comet, between 9 to 50 miles. I noticed that the crazy part is that next month, in July 6th, it's gonna cross the celestial equator. Now, I was trying to find out what the celestial equator is. The celestial equator apparently is variable. So it doesn't have a finite distance, or at least that's what I was told on Reddit, that there's no finite distance. But you know, when you look at the celestial equator, it's a line out here in space, and then the Earth's surface is right here. So it's like, it makes me think there is a distance between this. But apparently it's variable, it's whatever you want it to be, but I don't know, like. And you know, I was thinking about Apophis, and Apophis was gonna be close 20,000 miles from Earth. By the way, the one that hit the moon in 2019 passed by Earth 40,000 miles. So that was actually the last closest asteroid, the one that hit the Earth in 2019 during the lunar eclipse. That was the closest last one that passed by in a period of 2 years, 2021, 23 years, sorry. And then Apophis Apophis is coming in 2029. Alright, well, moving on. Luckily, the 2019 asteroid was small, but it did come real close. But Apophis is way bigger, and it's going to be even closer. So I feel like gravity comes more into play with something that's heavier and bigger. Now, with Apophis, it was mentioning that it's going to be closer than a lot of geosynchronous satellites. And I saw this Wikipedia page, and I saw this distance of this geosynchronous orbit, of satellite orbits. And, you know, I was like, it kind of looks like this celestial equator thing. But the geosynchronous orbit goes along the Earth's equator and not the celestial equator. But I feel like it's so similar that it's kind of like, okay, let's put 2 and 2 together. Now it's mentioning 20,000 miles geosynchronous, or even farther out than 20,000 miles, but I was like, okay, so K2 Panstarrs, you know what I mean? Like, so it's like, but it's mentioning on the 14th of July, it's going to be 1.8 AU, which is 270 million kilometers. So that's millions of miles away. So I guess it was misleading, like, because celestial equator, I don't even know what that is, but that was at the beginning of July, and then mid-July is when it's going to be farther from Earth. So that's why I'm questioning, what is the celestial equator, and what is the distance between the Earth's surface and the end of the celestial equator that's out in space. And they told me that it's variable. It's whatever the celestial sphere that you want it to be, or something like that, is what they told me. Like, there's got to be a specific distance. But this one is bigger than Apophis and Bennu combined, so it's it's mentioning as large as Hale-Bopp, and Hale-Bopp was a big one. It was a big one. But I do really want to see this one when it comes close to the Kalbarite star on the 21st of this month. But yeah, this one's got me like weirded out. This is the wobble path of this thing. Look at this thing, man. Right? Like this is gonna be the June 22nd of this year. These are the constellations: the Sun, Venus, and Mercury, and Pluto. This is the moon. This is our moon. Earth is right here. I'm guessing Earth would be right here. But it's not mentioning Earth. Mars is over here. There's a moon. I'm guessing this is our moon. So Earth is probably around here. And this is mentioning August, though. But it's gonna be... So July 6th is when it said it's gonna be entering the celestial equator. So it's denoting that celestial equator starts here. And then Earth is here. So it's mentioning August. It's going to be along the planetary alignment here. This is Arcturus. Boots. It's mentioning that it's going to be millions of miles away in mid-July. But where's the Earth? August. If this is our moon and the Earth is right around in here, then why doesn't it mention August here? Why doesn't it mention August in Wikipedia? It's just mentioning that it's gonna be mid-July, way far away. Perihelion, December 19th, close to the orbit of Mars. I don't know. Maybe I'm misinterpreting this, but it's going to be close to the orbit of Mars in December. But Mars is over here in this picture, so it's kind of weird. Close to the orbit of Mars. And Mars is mentioned over here, way over here, and December is over here. 2017 K2 Perihelion. I don't know. I mean, there is a planetary alignment going on, so. But this is a moon. Usually the moon is close to the Earth, so this is like mid-August. And I don't see the word Earth anywhere on here. It's kind of weird. But then it's mentioning that it'll be close to Mars's orbit in December. Orbit of Mars. December 19th. But the cloud, the trail of the cloud is long on this one, 500,000 miles long. December 19th, perihelion. Oh, why is Mars way out here? And this is mentioning 2023. It'll be close to Mars, not December 2022. Unless this is an old, unless it shifted course and then it's changed the trajectory, and this is an old photo. It says December 21, 2022. The center of Earth. Look at it. This says 2022 December 21. That's around Christmas time. It's mentioning location center of Earth. Okay, so center of Earth field 139.02 degrees by 135.59 degrees. It's saying the center of the Earth in December before Christmas. This is what this is saying, right? Oh man. Okay, so what is going on now? I'm so misled right now. I don't even know I can't even comprehend what's going on anymore. It says it right up here. Let me move the. It says right up here, location in the middle of the Earth. Now, is it talking about the asteroid being, or the comet being in the middle of the Earth, or center of Earth? I think it's just saying the middle of Earth, where it'll be perihelion. I don't know. The moon is here, the Earth would be here in mid-August, wouldn't it? I'm probably just misinterpreting this picture big time. Center of the Earth. Alright, hold on. It's mentioning, what is it mentioning being in December? It will reach perihelion December 19, 2022, close to the orbit of Mars, and will possibly be visible with the naked eye at 6.0 magnitude. July 14th, it will be 7.0 magnitude. Yeah, this is why I want to keep an eye on this one, because I'm so confused. I feel like there's not enough info on this one. 1.79 perihelion AU. NOID Earth. 1.10 AU. 165 million kilometers. So the NOID. Hold on. Anywho, yeah, so the MOID is the possibility of intersection so of the Earth. So this is of the distance of it from the Earth. 1.10, that's pretty far, man. I don't know. But the thing with this one is that it's a big comet, man. It's a big comet. And the Hubble is saying it's diameter of 11 miles. circular equivalent diameter of 11 miles. And it's been in the Draco constellation since July of 2007. It was actually recently in Agila, the Eagle constellation, and now it's getting into Ophiuchus constellation. So it went from Draco to Eagle to Agila to Ophiuchus. Now it's mentioning that it's gonna pass Messier 10. There's another K2, it's the K2 Panstarrs comet. That's another one that I was keeping an eye on. I feel like K2 Panstarrs, or even this one, I think it's going to be K2 Panstarrs. It's going to pass by the Eagle Nebula. K2 Panstarrs. This one's not, I don't think it's gonna come close to Earth. So this is Messier 25 or 26, Messier 26, Messier 11. I'm going through two nebulas, I think, or cluster stars. No, this is the moon. This is mentioning, well, this was in January of last year that it passed by the moon. No, I'm sorry, this was this year. 1/1 of 2022. (6/15/2022). So this is the path. Alright, so it seems like when it passes through in beginning of next year, it's gonna, the Earth is gonna be like way over here. So it's mentioning the green is the path is above the ecliptic plane. So the ecliptic plane, I believe, is the flat circles around here, the orbit circles. So this is gonna be, it looks like at the closest, the ecliptical plane is gonna be near Jupiter. But Jupiter is gonna be all the way over here. So this is the closest it would have been to the ecliptical plane, but it would be on Jupiter's orbit, but Jupiter is going to be over here. And that's that was this past February. So that time has passed. So it seems like it's going to be alright, I guess. But, you know, the 2017 Panstarrs one is the one that has my eye. Because the celestial equator thing with the, and then the geosynchronous orbit, satellite orbit, is kind of like, it looks similar. And this is going to be within that on the 6th for K2 2017. But it's saying it's going to be far. But this one is kind of like a scary one because it's 11 miles wide or 9 miles, whatever. Nearest approach. The nearest approach was in July of last year. And that was at 5.4 AU. July 14th, 1.8 AU. Alright, I think we're going to be good. Alright, so I'll go ahead and just leave this as food for thought, and we'll see you on the next video. Let me know what you guys think in the comments. Have a good one. Bye-bye.